In the first video, we talked all about the identifying and the naming of intervals. And if you missed that one, I'll put a link in the description so you can go back and watch number 1 before you watch this one. But there are a couple more topics related to intervals that I wanted to talk about today. The first one is the shorthand notation for different types of intervals. And this is really pretty simple, but it's something that's worth pointing out and mentioning. For all perfect intervals, whether they're fourths, fifths, or octaves, we simply put a capital P in front of the interval. So perfect P5 would be perfect fifth, P4 would be perfect fourth, and a P8 would be a perfect octave. Okay? For major intervals, we write a capital M. So for example, major third, major second, major sixth, and major seventh. Those would all be major intervals. For minor intervals, we're going to write a lowercase m. So for example, minor third, minor second, minor sixth, minor seventh. For augmented intervals, we simply write a capital A. So for example, augmented fifth, like that. And I'll just use one example because I'm running out of room here. And finally, for diminished intervals, we write a lowercase d. So for example, a diminished fifth would be written like that. So uppercase P for perfect intervals, uppercase M for major intervals, lowercase m for minor intervals, and uppercase A for augmented, and lowercase d for diminished. Okay, so anytime you see this sort of interval notation used, now you'll know what it means. So the second topic I want to hit today is the topic of compound intervals. So compound intervals are what we call any interval that is in excess of 1 octave, right? So remember in the last video we did intervals all the way from a second up to an eighth or an octave. So what happens if you go one step further than that? So for example, let's take that C major scale that we were using before, C, D, E, F, G, A, B, and let's go ahead and continue that scale up through the second octave, C, D, E, F, G, A, B, and end it one more time on a C. And I'm going to go through and I'm going to number each one of the degrees of this scale, 1 through 15. 1, 2, 3, 4, 5, 6, 7, 8. And once I get to 8, I'm going to continue on up through 9, 10, 11, 12, 13, 14, and finally 15. So compound intervals are really simple. All you do is you lay out a 2-octave scale like this, going all the way up to the second octave, which is number 15, and then you name the intervals the exact same way that you would with the single octave intervals. So as an example, a C to D, remember we called that a major second, and I'm going to write it using the notation that we just learned. So C to D is a major second, right? But if we went from a C not to the D right next to it, but to the D all the way an octave above that, we would actually call this a major ninth, okay? Because D would be the ninth in this 2-octave scheme that we have here. If we did a C to an E, remember, ordinarily we called that a major third, but if we went from the C to the E an octave above that major third, we would end up calling that a major tenth. From C to F, we originally called that a perfect fourth, so P4. So if we go all the way up to the second F here, we'd call that a perfect 11th. So you can see that the major, minor, and I mean, the major and perfect intervals stay major or perfect even in the second octave. So really all we're doing is we're replacing the one octave numerical part of the name with the second octave numerical part of the name. So C to G would be ordinarily a perfect fifth, but now we're going to call it a perfect 12th. C to A ordinarily would be a major 6th. Now we're going to call it a major 13th. C to B ordinarily would be a major 7th. And now we're going to call it a major 14th. And then finally, from C all the way to C, from C to this C right here would be a perfect octave, right? But then you could also call that a perfect 15th, because from C to the C 2 octaves above would be 15 steps through that scale, okay? Another name for this interval from C all the way up to this C right here would just be a double octave. Makes sense. This is an octave. That's a double octave, right? So that's how compound intervals work. All right, so that brings us to the next topic that I wanted to discuss, which is interval inversion. So if you recall in the first video, I talked about how if you invert an interval, which means take one of the notes in the interval and put it in a different octave while the other one stays the same, then it changes the name of the interval, right? So the example that I gave in the first video was that if we had a C right here and the F above the C, that this interval has one name, right? Whether we measure from the C to the F or the F to the C, that distance still has one particular name. But if we were to take this F and we were to move it down into another octave, so kind of leapfrog the C to put the F on the other side of the C, then this interval, the interval between this lower F and the same C, has a different name, right? So taking this note and putting it down here in that octave, that is interval inversion, okay? There are two basic rules that we use to rename the interval after we've inverted it. The first rule is called the rule of 9, okay? And the rule of 9 is very simple. All you need to know is that the numbers, or the numeric parts of the name, of the original interval and the inverted interval will add up to 9. So for example, a perfect fourth, which this happens to be a perfect fourth between a C and an F, when we invert it, that perfect fourth is going to become a perfect fifth. So 4 plus 5 equals 9, right? As another example, if we do a major third, that major third will become a minor sixth when it's inverted, because 3 plus 6 equals 9. And now you might have noticed that the major third became a minor sixth, right? So that brings in the second rule. And this is just sort of like, these are some rules that you're just going to have to sort of memorize when you're working with intervals. Major intervals become minor when inverted, and vice versa. So major becomes minor, minor becomes major. Perfect intervals stay perfect. Augmented becomes diminished, and diminished goes to augmented. So, for example, a major seventh inverted would become a minor second. There's our rule of 9. 7 plus 2 is 9. And there's our major to minor rule, right? Major intervals become minor when they are inverted, okay? So let's do another example. An augmented fourth, when inverted, becomes, well, our rule of 9 would dictate that it's going to be some kind of fifth, because 4 plus 5 equals 9. And our second rule dictates that augmented intervals become diminished intervals. So an augmented fourth, when inverted, becomes a diminished fifth, okay? And in a similar way, for example, a diminished fourth and augmented fifth when you invert it. Okay? So those are the basic rules of interval inversion. All right, so I want to wrap up today with just a few little odds and ends about intervals, questions that might have come up while you were watching the first video. The first one has to do with this little chart that we made in the first video. Remember, if we shorten an interval by half a step, perfect intervals become diminished, and they become augmented if we lengthen them by a half step. Major intervals, if we shorten them by a half step, they become minor. If we shorten them by 2 half steps, they become diminished. And if we lengthen a major interval by 1 half step, it also becomes augmented. So what you might be asking is, well, what happens if we lengthen a perfect interval by not 1 half step, but 2 half steps? Where does that take us? Well, that would just be, so like if I say plus 2 half steps from a perfect interval, would just be a doubly augmented. And the same thing applies when you get all the way down here to diminished. If we're already at diminished and then we go 1 more half step shorter, that's just a doubly diminished, right? And that applies to both perfect intervals and major and minor intervals. If you go further up the chart than this, it's just doubly augmented. If you go further down the chart than this, it's just doubly diminished. And that's all there is to it. Okay, so next let's talk about melodic versus harmonic intervals. A melodic interval is basically like if I were reading left to right on this staff here, and I saw an interval like this. Let's just put some stems on here for good measure, right? This right here, this interval would be a melodic interval because the notes are played in sequence, okay? So melodic intervals are played in sequence, not together. Harmonic intervals would be something like this, where we have 2 notes that are played at the same time as a chord, and that would be a harmonic interval. And I don't think my stems were actually pointing the right direction there, but I'm just going to let that slide for now. So that's the difference between melodic and harmonic intervals. Melodic intervals are played in sequence, one after another. Harmonic intervals are played together as a chord. All right, and finally, I want to wrap up today by talking about this idea of enharmonic intervals. And there's kind of an easy little phrase that you can remember to remind yourself what enharmonic intervals means. And these are intervals that have a different name, but they sound the same. Okay? So over here, I've written 2 intervals that we're going to look at. And at face value, these intervals look completely different, right? So we have a G going to a B flat, and then we have a G going to an A sharp. So right away, if you know anything about music, you're going to recognize that a B flat and an A sharp are actually the same note, just named differently, right? And if you play this on the piano, you're going to see that you actually go to the same place both times, right? A B flat and an A sharp, there's no difference there. But we do name these intervals differently, right? So if we look at a G to a B flat, let's figure out how we'd name that. Well, we have a G, an A, and a B. There are 3 letters in between, 3 letters in that interval, so it'd be some kind of third, right? And then we'd have a G to a G sharp, A sharp. But then, well, we're actually not even going to A sharp because we're going to B flat instead. So how many chromatic half steps do we have here? That's 1, 2, 3 chromatic half steps. And hopefully you're starting to catch on to this by now, that a third that contains 3 chromatic half steps, we call that a minor third. Okay? Now a G to an A sharp, on the other hand, well, how many alphabetical steps are in that? Only 2, right? But then we also have the same number of chromatic half steps. We have 1, 2, 3 chromatic half steps. But it's got to be some kind of second, right? Because, well, we only have 2 letters in there, right? It's only G to A, right? So it's some kind of second. But it's a second that includes 3 chromatic half steps. A normal major second would have 2 chromatic half steps. And if you recall, if we lengthen a major interval by 1 half step, it becomes an augmented interval. So this would be an augmented second. So you can see that a minor third and an augmented second are actually the same interval, or they sound the same, but they're named differently. So that's the idea behind enharmonic intervals. All right, so that's it for today. Go ahead and check out part 1 if you haven't already. And if you found that helpful and you want to see more of the same kind of thing, go ahead and hit the like button and subscribe to my channel. Thanks. See you next time.